I just wanted to say a few words about the video we just watched about active transport. So we know that pumps force molecules to move from an area of low concentration to an area of high concentration. These pumps are actually integral membrane proteins, as you understand, and because you're causing movement from an area of low concentration into an area where it's already in high concentration, it requires energy. And so this integral membrane protein binds to ATP and utilizes ATP. You don't have to worry about the details of that, but it requires energy to do that kind of motion. And so I just wanted to add to this a little bit. I just want to address the obvious question of if the cell is impermeable to sodium, then how did the sodium get here in the first place? And so the answer to that is there are integral membrane proteins that are channels, which we've learned about, and these channels permit movement of ions. And so, for instance, because we have a high sodium concentration outside the cell and we have a low sodium concentration inside the cell, we know that due to the laws of diffusion, just simple diffusion, will cause sodium to move from its area of high concentration into its area of low concentration. And these ion channels permit that type of movement as long as that substance is small enough to fit through the channel, which ions are typically small enough. And so that's how sodium is getting in. It's, so to speak, like leaking in through these channels. Now, we say that sodium is impermeable, not because sodium can't get in. It actually can enter into the cell through these leak channels. We say that sodium's impermeable because once sodium does come in, we're going to use energy to kick it back out using active transport. And because we take sodium and we kick it back out, this is what's known as selective permeability of the membrane. It's not a matter of being, say, like a filter, where if it's too big, it can't cross the filter. For instance, dust and debris can't cross the furnace filter, or the coffee grounds don't cross the paper filter. It's just based on size. Do you see how in the membrane it's not based just on size because these leak channels are going to permit movement? And so when sodium sneaks in, we're going to use active transport to kick it back out. And the same is true for potassium. I can see that we have a high potassium concentration inside the cell. Okay, they're showing us all that potassium. I can see very low potassium concentration outside the cell. Therefore, potassium is going to want to move from inside of the cell to outside of the cell, right? Through just plain and simple diffusion. And that's going to happen through those leak channels. But what we're using active transport for, and why we're saying that this is, pretty much impermeable, is because when potassium does leak out, we're going to use energy to recapture it and put it back in.